All right, now, has anybody here ever debugged anything? OK. Has anyone here ever debugged anything where they didn't have access to the source code and it had to work on Black Friday?
Hey folks, I'm Simon. Thanks for having me. I'm here to talk about underhanded debugging tactics you can use the next time you need to tackle a bug in production. So real quick, here's some background on me. I'm a senior engineer at Rent the Runway based out of New York City. RTR is an e-commerce platform where you can rent your dream outfit. P.S. We're hiring, so come talk to me afterwards if you're interested. I'm also a part-time instructor at General Assembly in New York. Sweet, so let's talk about debugging. At some point in your career as a software engineer, you're going to encounter a bug that's only reproducible in production, which means it's time to debug in production. Honestly, it's one of the most stressful moments as an engineer when you encounter a bug in a production environment that can't be reproduced locally. It's probably how most of us would feel. It's even worse in whiteboard interviews. We're just saying a lot. My favorite time debugging in production is when we're trying to launch an important new feature by Black Friday. A vendor we were using couldn't provide a testing or staging environment, only a production one. So we couldn't even test the flow end to end without deploying to production. When any issues came up, it was impossible to debug them locally. It was quite a wild journey. So, real quick, let's review the different deployment environments we might typically have. Engineers typically develop against a local environment where you can edit your application directly, put in breakpoints, use a debugger, all that good stuff. After developing a feature locally, the code is usually promoted to a QA and then a staging environment. We can't usually edit the code directly in these environments. Just like with production, this makes it tricky when bugs appear in these environments. For example, it's pretty rough when a QA analyst finds a bug on a QA environment, but you're unable to reproduce it locally. Great, so let's start to go through some tactics you folks can use the next time you debug an application in production. Or honestly, really anywhere that's not your local environment. I learned all of these tactics the hard way, so you folks can benefit from my frustration and lost hair and stress and all that. So the first tactic is to not panic. If being blissful is too much to ask for, at least be mellow. It's hard enough debugging a complex application, so remaining calm is essential. Let's review the overarching philosophy behind the debugging tactics we're going to see. We know that when developing locally, as we usually do, we can edit our code and step through it using a debugger when we encounter a bug. If we think about it, our debuggers give us input and output information. So when debugging against production, we need to find a different source for our input and output introspection. This means we'll need to play detective. It usually helps if we ask ourselves questions like, how do I know what code has been executed? With what data? Can I do anything to get more introspection into the system itself? If we don't know what's been executed, can we make a hypothesis and test it? What are the boundaries or interfaces in the system? Essentially, what we're doing is we're applying the scientific method to a running application. In order to apply this scientific method properly, we'll need a good overview of our architecture. For this talk, let's imagine we have this setup up here. There's a really good chance all of our stacks are slightly different, so I'll try to be as technology agnostic as possible, aside from React. This is a React conference. So on the left, we have our clients, which are web browsers. As our request goes through the app, it'll go through to the CDN, and then our load balancer, with our application servers next, that is our backend. And finally, our application servers get data from the database. From the architecture diagram, we can see these boundaries between the systems. At each boundary, we have input and output. Later on, we'll take a look at some tactics for actually exploring these boundaries or these interfaces. I'm also going to assume that you have access to your application's code base and can run it locally. This enables us to debug our local application in parallel to production. We can start to compare our local input and output to what we've gleaned from the production application. This also raises the question, what could actually be different between our production and local environments? An easy first step is to ask ourselves, is there a configuration difference between our local application and production? These configuration differences are often the cause of these unreproducible bugs. I would recommend becoming familiar with your stacks build process, particularly any flags passed to module bundlers like Webpack. This is a place where all these bugs tend to pop up first. So, let's start at the beginning in our debugging journey, all the way at the beginning with the CDN, the first place our requests go through. So, CDN is the first step in our request journey. CDNs are content delivery networks. They're usually geographically distributed servers. If we use a CDN, our end users will likely have requests fulfilled by servers that are geographically closer to them, and they'll see performance gains. CDNs are also used to cache assets like CSS files, JavaScript files, image files. You can also do things like full-page caching or partial caching in CDNs. That all sounds pretty great, right? Unfortunately, CDNs can also cause these hard-to-reproduce bugs in production. Depending on how complex your CDN setup is, you might run into stale assets, which means your end users could get served old JavaScript files with breaking changes. That's not good. There can be issues with the redirect rules, firewalls, and much more. We definitely should use CDNs in production, but we need a strategy for ruling them out as a source of a bug. So, one weird trick to rule out CDN issues is to bypass the CDN and just hit your origin server directly. So, it'll rule out any issues caused by a CDN misconfiguration. Most companies tend to restrict making a request to the origin server to internal networks, so you'll need to watch out for that. But honestly, if your bug is gone when you hit your origin server directly, then your problem is probably solved. You'll want to investigate how your CDN configuration caused the issue. It might be related to the deploy process of your application. CDNs allow for a form of caching. So let's focus on handling bugs caused by caching next. So please read this while I drink some water. Jeff Atwood was not the first person to tweet that, just so you guys know. We can have caching client-side in the browser and also server-side via in-memory caching and databases. So let's divide them up. Client-side caching can occur via web storage, cookies, and service workers. Here's an example of where we fix an issue with client-side caching using local storage by flushing the entire cache. Note how that last to-do item right there looks a little bit wonky, and it's actually missing. So it's missing right there. We are going to refresh the page and open up the developer tools, and we'll take a look at what caching is being used. Once we've cleared out that local cache, the issue disappeared. That last example was pretty simple, but even for more complex applications, I recommend ruling out client-side caching first by using an incognito window or a different browser. You can also just flush the cache, as we did. I promise, it's going to save a lot of time. For server-side caching, it's hard to get insight into what's actually being cached. You could check your application's logs or check the cache directly if you have access to it. However, the easiest solution is flushing the entire cache. I know that sounds like a cop-out. It is the equivalent of turning something off and on again, but caching issues tend to be hard to debug. So this is a quick sanity check. If your bug still occurs after this point, it's probably not caused by any server-side caching. And just as a quick note, fair warning, please make sure you're very careful when clearing out any caches. Don't take your applications down when trying to debug them. So we just saw how caching in our applications can take a turn for the worse. Let's move on to actually taking a look at the client-side JavaScript running in the browser. So this is the JavaScript running in our clients, that is the web browser. It's running on our users' browsers. And honestly, debugging client-side JavaScript is a lot of fun. We can see our client-side JavaScript directly in the browser. Unfortunately, one downside is that it tends to be minified, especially for files in production. So that makes things a little bit interesting. So why don't we go back to one of those previous questions? Can we do anything to get more introspection into the system? we can start to use source maps to help debug any compressed JavaScript. You can generate one from the tool you're using to compress your original JavaScript files. So after generating the source map, you can use Chrome's DevTools to apply it directly. Let's take a quick look. So I'm adding in the source map from that URL. And here we have the actual uncompressed file itself. So also note that when you typically generate source maps, there's a way to do that so that the browser's DevTools can load them automatically without having to insert a URL for their location. There's usually a configuration setting for that. In case you can't generate a source map, that does happen at times, there's a preprint option in Chrome. So let's take a quick look at it. It's not going to help for any uglified code where the variable names or other identifiers get mangled, but it honestly makes the debugging experience much, much smoother. So at this point, once our code is usable, with client-side JavaScript, we can actually put in arbitrary breakpoints using the browser's developer tools. These breakpoints give us the input and output data we want from our application. So we want to make sure we place the breakpoints at the right place. So we're going to use a local copy of our application as a wayfinder when examining these production files. We can map identifiers from our local files to identifiers in the minified code in order to determine where to actually place these breakpoints. Let's imagine that we're focused on the edit functionality in our small to-do app. So looking at a small snippet of that code, we can see some good identifiers. We have this enter key variable. So let's see if we can use that and search for this function in our minified code. So let's take a look at this in action. We're going to search for that enter key identifier across all the JavaScript files in our application. We'll find the appropriate file, we will beautify it, and then we're going to find it within that file itself. So eventually we'll get to the method that we care about, we'll put in a breakpoint and see if we actually hit that method. So here we've hit that method, we stopped our code, and now we're going to start to take a look at the actual input and output information in that method. After you have your breakpoint in place and you've been able to hit it, you might notice that the bug at hand is actually tedious to reproduce. There's often an error scenario that we want to hit, and it gets hard to reproduce when we have to deal with collections, when we have arrays of things. So I recommend using conditional breakpoints to only pause when the error condition for that bug is triggered. It is honestly the worst thing to do is just sit around and keep hitting that play button for hours. And sometimes you can even miss the scenario that caused the original bug. So let's take a look at this in action. We're going to load the page, our app is broken, we see that scary runtime error right there, and it's happening when we're setting the initial state on this component. Looks like we're trying to access a property that's not defined. So we'll place our breakpoint, and we hit the breakpoint, but in this time, we have that value. We haven't been able to hit the error scenario just yet. And there are a lot of items in this collection. It's going to take us a while to hit this error scenario. So we're going to add in a conditional breakpoint, and we'll only stop when that to-do object property isn't available. So there we go. We just hit that scenario. We refreshed. Now we can see what's happening. The title object property itself is just not there. We take a look. The property itself is not there, so we try to access the title property on that object. We can't. We'll run into this error. So instead of having to navigate through every single item in the collection, we set a conditional breakpoint to stop just on that error scenario. Going even farther, in that previous example, it was written using React, right? The props kind of gave it away. Why don't we utilize React's DevTools? With React's DevTools, we can get insight into the actual prop and state values without needing to set breakpoints. If we think about it, these are the actual inputs to our components. So let's take a look at that in action. This to-do app is also broken, but it's broken in a slightly different way. So let's see what's going on. So we're going to open up the React DevTools. We're going to focus in on the broken component, and we'll take a look at the props. So that one was good, right? It had a title. This one, there's no title, and the state is also empty. Kind of explains why it looks kind of broken, too. So we were able to do that without setting any conditional breakpoints or any breakpoints in general. We use React DevTools to help us debug to that point. focusing in on this idea of props and state values and even large data structures, I recommend actually serializing that data, taking it out of the browser environment and using command line tools to inspect it. So here, we're going to serialize our previous props and our props. We're going to use json.stringify to actually do the serialization. We'll copy it from the command line by using Chrome's copy method. And we'll do that the same thing for the props property itself. We can save the serialized JSON. This is just a string that's on our clipboard into actual files. So maybe we'll call them pre-props and props.json. And then we can use tools like the npm package JSON diff to actually compare these files, to actually compare those data structures. If they're large enough, it makes sense to take them out of the browser and do them in an environment where they're first-class citizens. So here we can see the title change between our previous props and our props, along with some of the completed property values. This is one way where we can make the introspection easier by taking things out of the browser and using actual command line tools that were built for these kinds of things. We've been looking at the data in our to-do app and how it's been broken along the way. But that data, it has to actually come from somewhere, right? So let's take a look at that data transfer process next. And it raises the question, how do our applications actually get the data that they need? In some cases, we make Ajax requests from the client. The requests are eventually handled by our application servers. So we have this boundary right here. Unfortunately, that means that we can have bugs when we actually create these requests in the clients. We might have bugs when we handle the request server side. And then we could have a bug when we actually handle the response client side as well. That means that our goal should be to get as close as possible to the actual request, the actual data transfer processes. And we are very lucky because we can actually inspect these Ajax requests directly in the browser. So here we can see the Ajax requests that are made every time we add a new to-do item. We can also see that a request will be made when we mark a to-do as completed. If you notice, there is also this initiator column. If we hovered over it, it would actually tell us what caused that request, along with the stack trace for the request. By inspecting the Ajax request in the network panel, we can see if we actually made the request successfully, if it gave us back the expected response body, rather if it provided the expected request body along with we got the correct expected response. Going even further, we can actually replay those requests without the browser by using curl to see how our backend handles these requests. We're going to isolate our system to just these requests. We can grab the curl for each request and then execute it ourselves from the terminal. We just copied it, we're going to paste it. It has all the flags that we care about. And here, I'm going to pipe it to JQ, a separate program, so it'll parse all the JSON for us. So we used Ajax requests here as a convenient example, but you can recreate any HTTP request using curl. We just have to make sure that we have the correct flags and other settings. It might require some additional work, but it's still doable. Even better, we can actually edit the curl commands. So editing curl by hand is a recipe for sadness, so I recommend using a tool like Postman instead. And here, we imported the copy curl command into Postman, and then we changed the contents of the request. And then if we reload our app, we can see that the request went through, and we can actually see the new to-do item that was created by using Postman in the application itself. So by using a tool like Postman and narrowing it down to the actual requests, we can start to test different parts of our application. What's great about this is that if you suspect that there's an actual race condition in your code, instead of trying to reproduce it manually yourselves, you can write a script that makes these HTTP requests for you. So here I have a sample of one that's a bash script. And in this snippet, I'm continuously repeating post requests to 2 different endpoints in a loop. If there is a race condition with those endpoints, it might happen with database transactions, we should be able to reproduce that race condition. So I would also advise being a little bit careful around this. You don't want to accidentally DDoS yourselves. You don't want to create a lot of bad data. you might want to run this script in a staging environment first. This is a great way to try to reproduce a race condition. And sometimes these happen with things that might look synchronous, but the actual database transactions might be slightly asynchronous. Try it out. Okay, so let's move on to tactics for actually investigating the code on our servers themselves. So fair warning, this is a part where introspection is a little bit more difficult. If you have tracing and log management and other similar tools, please just use them. There's Splunk and Datadog and New Relic, all those fun companies. All the following advice will still apply if you have those tools. It'll just be a little bit easier to apply the advice. So here are our production application servers. These servers are handling requests from actual users. So we can't just edit the code on them directly or apply breakpoints or anything like that. What we can do, however, is try to match entries in the log files to actual logging code in our application. This way we can see what code was executed or what functions were executed. What we want to try to do is isolate the code paths to specific endpoints by using curl. We're going to have to create the curl command ourselves probably, but the process is a lot like the Ajax technique we just saw before. The other thing I would recommend is when your production application is taking traffic, you're going to see a lot of messages in log files. So I recommend finding a GUID or some sort of other similar identifier when searching for the entries that are relevant to you. Otherwise, it's going to be a wild goose chase because you'll see a lot of entries in your logs from actual users. So here, we're going to try to get the ID of one of our to-do items and use it as a GUID. So we can see that ID right there, and we can start to use that ID as a way to search our application's logs. So here, this was a sort of interesting example because we used iterms find feature, but normally we would use a tool like grep. I just use iterm for simplicity. Normally we would use a tool like grep to search through our logs for that GUID. And if there is no GUID, you can actually create your own, depending on how your application handles optional query params. So I'm going to create a new to-do item using Postman, and I'm not going to see anything in the logs by default. That would help me identify the request. What I'm going to do is I'm going to add in this silly parameter here, foo equals bar, and I can search for that in the logs. This way I can identify my request, the one I'm using to test the application, and isolate the bug from real user requests. Cool, we're almost done, and these next two tricks are very sketchy. Like, honestly, like very sketchy. I recommend asking for permission before doing these. Things can get a little bit dicey, especially with compliance for things like PCI compliance and HIPAA. So just ask permission first. All right, so the first one is using a tool like TCP Dump. It's a command line packet analyzer to actually inspect network traffic on the production servers. So you'll be able to see the requests that are being made, the request bodies, all that good stuff. This is extremely helpful because we can identify the actual request data flowing into our application on production servers before it's handled by our application code. And we don't have to modify any of the code ourselves. We can try to pinpoint the issue to the HTTP request itself, the data in the request, and if it's not that, it might be the actual application code itself. Here's what it might look like. So the command is TCP dump. Here we're narrowing down to a specific port. If you have microservices or you have a lot of ports on your application, you might want to take a look at this port for that application. And we're using grep to narrow down to HTTP traffic, and we'll take a look at 20 lines before and after our request. You can get even fancier with other command line tools. If you want to get even fancier than that, you can actually export that packet dump from your production servers and use a tool like Wireshark for easier analysis, rather than relying on grep and other friends. So let's take a look at this in action. So I'm starting up TCP dump. I made some requests. I can see the requests in my logs. Here, I'm going to make a request from Postman, and I'm hitting this super secret endpoint with a secret parameter, and I should be able to see that in the actual logs that TCP dump provides. So we can see that it errored out, and the parameters and headers are still there. So we can take a look at the actual traffic our production servers are taking and narrow it down to the test that we made to isolate any bugs. The next one is also very sketchy, but we can remove one of the application servers from the load balancer and actually deploy it directly with breakpoints, maybe with additional logging. So here's what it might look like. We took out that very bottom application server from the load balancer. It's not going to take any customer traffic. No customer will get a bad experience. But what that means is that we can put in our breakpoints, we can add in additional logging, and actually see what's happening on that application server. If we had a configuration bug that we couldn't determine before, by this point we should be able to figure out what's happening on just that server. All right, the last and final tactic, and honestly the best tactic, is to give up. And there's always an and add logging in key code paths. So we can deploy our application with this additional logging as part of the normal deploy process, treat it as business as usual. And what's great is that in the future, we can use the log messages to reproduce that bug. For client-side logging in the browser, you can use tools like Sentry or New Relic to capture any of those requests. You can even go further. If you're so inclined, you can also page yourself when those bugs appear. I wouldn't necessarily recommend this, but if you are super invested in this bug, it's good to know as soon as possible so you can attempt to reproduce it in the same conditions. All right, so let's start to wrap up. We went through a few underhanded tactics for debugging in production. They really revolved around our ability to actually investigate our applications without editing any code. I hope they were helpful when dealing with your next production bug. That's all, folks. Thank you so much.